The Perseverance rover has been exploring the 45-kilometer-wide Jezero crater on Mars for over 500 days. Perseverance is also known as Percy to its friends and to people who want to forget that a seventh grader won the competition to name the rover with a precociously beautiful essay about how rovers represent humanity. But what is Perseverance actually doing on Mars? Apart from collecting rock samples and testing whether oxygen can be produced from Martian air, Perseverance is looking for biosignatures, signs of possible past microbial life, as well as habitability, past environments that were capable of supporting microbial life. So, after more than a year, has the Perseverance found life on Mars? Well, Perseverance hasn't actually been looking for life directly. It's been collecting evidence that will gradually build towards answering the question. These things take time. For example, Perseverance has been taking photos, like a lot of photos. The 23 onboard cameras have so far sent back over 100,000 holiday snaps. These photos are data that will tell us about how the Martian landscape was shaped by water, an essential piece of the puzzle helping to build up a picture of past life on Mars. Perseverance has also been the carrier vehicle of a helicopter named Ingenuity. Ingenuity flew for the first time in April 2021, and this was the first powered flight on another planet, less than 120 years after the Wright brothers first achieved it on Earth, although they weren't flying a helicopter launched from a robot remote-controlled from 170 million kilometers away. Slackers. Perseverance has so far launched Ingenuity on a total of 19 flights. Fine, I hear you say, but how does that help search for life on Mars? Well, Ingenuity has cameras that are creating a high-resolution 3D map of the Martian surface, again providing clues about the geology and weather on the planet, important factors in the emergence of life. Ingenuity is also known as Ginny to its friends, the kind of people who give human-sounding nicknames to robots, probably loners, Jedis, and Tom Hanks. Okay, so a helicopter on Mars means even more pictures. Is that literally all this mission is about? No. It's also about pulling sweet oxygen directly out of atmospheric carbon dioxide. The onboard oxygen extracting equipment can produce 12 grams of oxygen per hour, enough for about 20 minutes of air for a human, which might not sound a lot, but tell that to Arnold Schwarzenegger when he's gasping for air in Total Recall. And now the process has been demonstrated, it could be scaled up to provide oxygen for future explorers and colonists. Perseverance has also drilled into the surface of Mars to extract rock to a depth of 6 centimeters, and these rock samples will eventually be returned to Earth for analysis once the mission to return the samples has actually been built, like closer to 2030. The first samples won't return to Earth before 2031. Alexa, set a reminder. Perseverance's photographs of the Jezero crater have shown the remains of a dried-up river delta. Jezero used to be a lake fed by a 200-kilometer river, but they've actually been dry for 3.7 billion years, which means there could be evidence of ancient aquatic life in the crater, if the rover stumbles on the right rocks. Digging into the surface, scientists expected to find layers of rock or sediments. Sedimentary rock normally forms from particles and dead plants and animals that fall to the bottom of seas and lakes and get gradually compressed and hardened over millions of years. But what Perseverance uncovered in the bottom of a dried-up Jezero crater was igneous rock. This kind of rock has larger crystals inside, which are formed when molten rock slowly cools. This means that there could have been an ancient lava flow through the crater, spewed out by a long-extinct volcano, slowly cooling into the rocks that Perseverance has been drilling into. Water flowing through this ancient volcanic rock would have been a habitable zone for ancient microbes, more evidence that Perseverance is looking in the right place. In fact, one of Perseverance's onboard experiments has found organic molecules in the crater. Organic here doesn't have anything to do with recycling your brown waste or growing food without fertilizers. Organic molecules are simply clusters of atoms that include carbon. Organic molecules are not alive, but they are necessary for life. At least, they're necessary for carbon-based life, which is the only type of life that we know of so far. Apart from that rocky silicon blob from Star Trek that Spock mind-melded with and went all incoherent. I mean, you try reading a rock's mind and see how much sense you make. Okay, so no actual little reptile kangaroos or talking plants with rows of razor-sharp teeth, not even a confirmed bacterium, but lots of positive signs that things are moving in the right direction. So, what's next? Into the river delta. Perseverance will drive into the dried-up river delta area that used to feed the Jezero crater with water over 3.5 billion years ago. Perseverance has made good time, covering as much as 240 meters a day, because it drives itself. Autonomous driving is much quicker than relying on a driver millions of kilometers away, working against a 20-minute time delay. If a driver on Earth noticed on their screen that the Mars rover was in danger of an impeding collision and steered right, it would take about 10 minutes for the signal to reach Mars and actually steer the rover to the right. Long after, it had actually burned through the stop sign and demolished a gaggle of Martian school gerbils on their way to kindergarten. And then it would be another 10 minutes before the driver received the images of the rover, now far away from the carnage of the school crossing, suddenly turning right, falling off a sheer cliff, and shattering on a rocky floor hundreds of meters below. No sir, not this rover. This rover drives itself. But autonomous driving is not all plain sailing, and not just because driving and sailing are entirely different forms of transport. Those rocks on Mars that have proven so informative can actually cause problems of their own. Who would have thought that a rock, or indeed a hard place, could prove difficult in some way? Well, NASA engineers noticed a bit more friction in their mechanical systems than they were expecting when comparing the performance of the Mars rover to its identical twin rover on Earth, which they used to model the behavior of the one on Mars. The team at Mission Control got the Mars rover to remove a drill bit and undock its drilling arm, and then take a picture of its own insides. Luckily, the rover is not self-aware, as far as we know, because no one likes to be told to pull off their own arm and take selfies of the bloody socket, and certainly not by telephone. Anyway, the rover's photos revealed a small pile of pebbles and dirt within its otherwise pristine metal innards. The pebbles were pushing on the drill bit, shifting it out of its correct position and causing friction, inefficiency, and heat loss. A quick spit and polish did the trick, and the rover went happily on its way with its arm and drill bit reinstalled successfully. I suppose that would be a pretty big upside if the rover were self-aware. Everyone likes to be able to easily and painlessly reattach their own arm in the event that it becomes separated from the rest of the body. Am I right? Anyway, the engineers sorted that problem, and it might only sound like a minor problem, and that's because it was. But when you're trying to maintain a $2.7 billion mission, riding on a 1-ton piece of hardware the size of a car from millions of kilometers away, and with a signal delay time of 20 minutes, it's better to be overly thorough than to cut corners. Collecting the rocks themselves was also not as easy as expected. The very first attempt to collect a rock sample didn't work. I mean, everything did work, but the actual rock sample never made it to the collection tube. Despite this, the NASA engineers were pretty confident, and they assumed that the problem wasn't with their Mars rover robot, but with the Martian rock itself. And they were right. After a mere 2 days of sweatily scratching their heads and jabbing at keyboards, they determined that the rock that Perseverance had tried to collect was too powdery, and it shattered before it could be drilled up as a pencil-thick core of rock. Bummer. In fact, the Perseverance rover was intended to take samples of the less brittle igneous rock, rather than the more crumbly sedimentary rock, which was collected by an earlier mission, the Curiosity rover, which landed on Mars 10 years ago in 2012. And that's it, so far. Thousands of photos, thousands of meters driven, the first powered flight on another planet, manufacturing oxygen from CO2 in the thin Martian air, drilling into rock, failing, getting crumbs in its innards, cleaning itself, finding better rock, collecting it, and driving further into a river delta that dried up before Earth even had its present-day atmosphere, let alone any complex life. We're learning about the deep history of our solar system, one painstaking rock crumb at a time. And we're also learning about the geological process on Mars by generating a high-resolution 3D map of its surface by helicopter. So, has the Perseverance found life on Mars? No, not yet. But it's no slouch. See you about those rock samples in 2031. Enjoy the video? Why not leave a like and hit the subscribe button for more videos just like this one? Thanks for watching.